Hello, I would like to welcome you to this second course in a specialization on algorithms for battery management systems. My name is Gregory Plett, and the title of this course is Equivalent Circuit Cell Model Simulation. This course is the second one in a specialization that looks at proper management and control of battery packs, and usually battery packs that comprise many cells. I assume that you have successfully completed the first course, which talked about some of the requirements and background information in battery management systems. If you have not done so, then please do so before you start this course. In that course, you learned about state of charge and state of health, and indeed to be able to estimate the state of charge or state of health of a battery system, or even the available power or the available energy, we require mathematical models or descriptions of how battery cells work. These mathematical equations that describe something are what we call a model, and that's the focus of the first part of this course. Once we have the equations that describe a model, an additional benefit to having that model is that we can use it to develop computer programs to simulate how individual battery cells and battery packs will operate in a realistic environment. And if you also happen to have a description or model of the load that will be powered by the battery, you can combine those two models of the load and the battery to be able to co-simulate the operation of both together and how they will operate together in an overall system. This can be very helpful to aid the evaluation in a system design. So in this course, you will learn how to write equations that describe how a battery cell's voltage will respond to a change in its input current stimulus. You will also learn what laboratory tests you must perform in order to gather the data required in order to compute the parameter values or the constants that go in the generic battery model equations. You will learn how to analyze these data that you have collected in the laboratory to compute the values of these parameters. And you will learn how to write computer code that will simulate the battery cells in operation and even battery packs in operation where the pack comprises many cells wired possibly in parallel or in series. And we will develop these codes using the Octave programming language, which is very similar to MATLAB if you have any exposure to that. You will also learn how to simulate a representative battery load if you choose to take the honors section of this course. After completing the course, you will have gained several valuable skills. You will be able to state the purpose for each component in an equivalent circuit battery cell model. You will be able to compute approximate parameter values for the unknown constants in an equivalent circuit model using data collected from simple laboratory tests on a physical cell. And going a little bit more in depth, you will also be able to compute more exact estimates of coulombic efficiency of the cell and total capacity of the cell from lab test data. You'll be able to use the provided computer programs to compute open circuit voltage and optimized values for all of the cell model parameter values. Then you'll be able to take this model that you have created and use it to simulate battery cells and battery packs in operation, and this will allow you to predict behaviors in battery packs when there are cell-to-cell variations in individual cells that are used to build the battery packs. And finally, if you choose to take the honors section of this course, you will be able to simulate an electric vehicle as a representative load. And this vehicle will be combined with a simple battery model, and this will allow you to do things like predict the sizes of motors needed and drivetrain components needed and battery packs needed in order for the vehicle to operate in a realistic environment. I've already mentioned a prerequisite for this course, and that is the first course in the specialization. And I assume that you have taken that course and succeeded at it, and that you have all of the required prerequisite knowledge from that course. In this course, we will be working with models or equations, and we'll be using a little bit of calculus, we'll be using a little bit of differential equations, and a little bit of linear algebra. So I assume that you have those skills in your background. We will be developing code in Octave, and it's not necessary that you have seen Octave before, but it is helpful if you have worked with Octave or MATLAB. Certainly you should understand the fundamentals of procedural programming from some language. And we're going to take small steps, and so we will build up our computer programs and our computer models in small steps so that you can gain confidence as we progress through the material. We're also going to study topics that are talked about in the optional textbooks that you see on this slide. We'll be covering some topics from Chapter 2 in Battery Management Systems Volume 1 on battery modeling, and some topics from Chapter 2 in Battery Management Systems Volume 2 on equivalent circuit methods. Both of these books are sold through Artec House. I stress that these books are optional. They are not required for you to be able to succeed in this course. However, I do believe that they can be quite helpful to you as a more permanent resource after you have completed the course and you want to refer back to what you learned and to refresh your memory. And I think that they will explain things sometimes in slightly different ways from how I will describe them in lessons, and so it might be helpful to have that different perspective. So again, I do recommend them, but they are truly optional. And this brings us to the end of this introduction to the course. The next step is to start to develop the sets of equations or the model that describes a battery cell using common electrical circuit components in order to do so. And once we develop this model, we will use that throughout the rest of the course and indeed throughout the rest of the specialization. So again, welcome, and I trust you will learn a lot and enjoy it.